as an example, in this Box Hunter and Hunter pilot plant example, what I'm going to need is a pooled S, and I'll remind you that when I showed you the data, that when I showed you the data, I showed you the, well, let's see here. Well, sorry. When I showed you the data, I included these sample variances over here. And what I'm going to do is basically average those sample variances. I will take sample sizes minus 1 times those things. All the sample sizes are 2. So I'll take 2 minus 1, or 1 times 2, 2 minus 1, or 1 times 8, 2 minus 1, or 1 times 32, so on. Add those up and divide by 2 minus 1 plus 2 minus 1 plus 2 minus 1, that is, I'll divide by 8. So S pooled is going to turn out to be nothing but the square root of 2 plus 8 plus 32 dot dot dot, the last one of those things was 2, divided by 2 minus 1 is 1, plus 2 minus 1 is 1. That is, there are 8 ones down there in the denominator, and when all is said and done, that's 2.83 grams. That's a measure of how variable are the yields for any fixed plant setup. And then my confidence limits for effects, and I might as well make, say, 95% confidence limits for effects, are going to be the output of the Yates algorithm plus or minus a t-value times 2.83. These data are balanced. The sample sizes are 2, so I'm going to have 1 over 2 times 2 to the p, that's 2 cubed, and then this number 2.306 is the upper 2.5% point of the T8 distribution. Why 8? Well, there are 16 data points, there's 8 groups, 16 minus 8 is 8, and that's the guy that I look up. Okay, so this turns out to be estimated effect plus or minus 1.63 grams. That is what comes out of the Yates algorithm. I can judge those values to be good to within about 1.63 grams. So let's go back here a few pages. Those numbers in that final column there are good to within 1.63. Only the ones that I put in yellow, that is this guy, this guy, this guy, and of course the overall mean, but only those effects, the A main effect, the B main effect, and the AC two-factor interaction, are bigger than the background noise. That is, the plus or minus 1.63 sort of establishes a level of background noise, and there's only those few effects that are clearly more than experimental variation. And so I come to the conclusion here that my eyeball analysis that picked out the 11.5, the 5.0, and the minus 2.5 was not a bad analysis because the rest of those values in that Yates table are in fact down in the noise range.